Lithium metal anode-free batteries promise higher energy density and longevity, but their biggest problem is the dendrites that form inside the battery and ruin it. QuantumScape claims it solved this issue with a proprietary solid-state separator, which prevents dendrite formation. Most batteries are designed with two electrodes, cathode and anode, an electrolyte, and a separator to keep the electrodes from short-circuiting. Electrons move between the anode and the cathode when the battery is charged and discharged. In the case of Li-ion batteries, the cathode is made of lithium-based oxides or lithium iron phosphate, in LFP cells. The anode is usually made of graphite, although new chemistries add silicon for improved energy density and performance. The anode is not only the heaviest component in a Li-ion battery but also one of the dirtiest, requiring intensive processing using toxic solvents. Tesla is trying to solve this issue using a dry electrode process, eliminating toxic solvents and cutting production time and costs. However, there's another way to solve this problem, which is by eliminating the anode altogether. The so-called anode-free batteries have been in development for years, but mass production has remained a dream. The anode-free batteries are only anode-free when they are manufactured. During the first charge cycle, lithium ions deposit on the negative current collector, creating the so-called lithium metal anode. This approach simplifies manufacturing, reduces costs, and improves the battery cell performance. If you're wondering why aren't all Li-ion batteries built this way, it's because the technology is far from perfect. In this case, dendrites grow inside the battery, eventually leading to a short circuit. Many battery startups and research teams are trying to solve this problem, each in their own way. Among battery startups that pursue lithium metal batteries are QuantumScape, Factorial, and Our Next Energy. Scientists at the University of Texas are also working on a solution and discovered that covering the copper current collector with an ultra-thin layer of lithium-activated tellurium solves the problem. The tellurium turns the lithium metal deposit into a thin, uniform layer instead of spikes, thus eliminating dendrites. However, QuantumScape has another solution. The battery startup announced it developed a proprietary solid-state separator made of ceramic material that prevents dendrite formation. Tim Holm, the co-founder and CTO at QuantumScape, says that the electrolyte is made of an organic liquid, whereas the cathode can be made using nickel, iron, or both. The result is the QSE-5 cell, with a standard capacity of 5 amp-hour, similar to other cells, including Panasonic's 2170 cells. It's also close in terms of energy density, at 305 kWh per kg, compared to 272 to 296 kWh per kg for Tesla's 4680 cells. This doesn't sound like a breakthrough, and Holm admitted it will be much more expensive, at least initially. However, as the technology is fine-tuned and production increases, it has the potential to produce much cheaper battery cells that could upend the industry. Speaking of production, QuantumScape is now shipping to interested parties B-samples of the QSE-5 cells, which are near production prototypes. Among the potential beneficiaries is PowerCo, the battery subsidiary of the Volkswagen Group. PowerCo has licensed the technology from QuantumScape and will start production at its future gigafactories in Spain, Germany, and Canada. This means the Li-metal cells will probably be first used to power a Volkswagen EV. However, we shouldn't get overly excited just yet. QuantumScape unveiled the QSE-5 cells during the Q2 2023 earnings call almost 2 years ago. At about the same time, Our Next Energy announced a similar product, the Gemini hybrid battery. None of them have been installed in an electric vehicle yet. Factorial's lithium metal cells seem closer to production, having already been tested in a Mercedes-Benz EQS prototype.